We'd like to show you 3 new iScaf 11 features today. Firstly, we'll show you the ability of iScaf to scaffold tanks with sloping ground away from the tank face, where internal and external legs require different heights. We'll expand that out to a more complex circular slope and a dance floor so that you can see how really difficult estimation tasks can be simplified with iScaf. Secondly, we'll show you the new feature that gives you the option to color code length and width elements separately in iScaf. Historically, they've been the same color for a bay length. Color codes simplify selection and recognition of different scaffold lengths in your plans and by your constructors on site. And finally, we'll demonstrate the new iStairs feature that allows a stair-shaped profile or surface to be created, and multiple stair surfaces can be combined to create even more complex sloping scenarios. So let's start with our first demo, where we have a circle or tank here and have applied a standard slope line out from the center of the tank. We then use the tank surface command to create a 3D surface or complex slope that follows a circular sweep that we'll be able to apply to the bays created by the make tank command. If we fill in the details on the make tank command and set up our bay layouts and options, and select the tank that we want to build around, it will automatically generate the bays that we require to follow the settings we specified. We have the bays produced in the circular alignment, and we'll change to shaded mode to more clearly see the tank profile. And the final task is to attach the slope that we've defined to those bays. iScaf allows any scaffold bays to be attached to a slope or surface. So we've clicked the Attach Slope icon, and we can now attach the surface to a set of bays. Now that we've selected the slope, we just select all the bays, right-click to finish, and when we open Edit Wall Options, we'll see there is a slope attached to those bays. So we can see here that slope E1B is attached to that bay. When we build 3D, we'll be able to change into perspective view so it mimics real-world conditions, and shaded mode so that it shades in all the surfaces and elements. Now convert our plan to 3D. Select all the bays by right-clicking, and we generate a build attached to the slope. Rotating the view, you can see that the outer legs have extended down to accommodate the slope that we planned. It has added extra ledges and bracing on the outer legs, as well as adding the additional standards to the outer legs. Note this drawing is not fully engineered yet and additional edits can be made. Now I'd like to show a more complex slope that extends out further with an extra circular hill on the outer edge with a dance floor placed on it. So we've built this to 3D, which allows us to clearly see how the design accommodates the complex slope profile. So as we pan and rotate around, we can see how this scaffold follows the surface quite nicely. iScaf also automatically adjusts gear to fit and updates the estimated gear list, ready for pick and invoice accordingly. Now let's move on to our second demo. iScaf color codes for bays have been based historically on the length of the bay. Here's an example where the 2.4 meter bays are all green and the 1.8 meter bays are blue. iScaf has a new feature that allows you to optionally nominate color codes for widths or transoms to be distinct from their bay length colors. We switch to the new color width option here, and you can see the widths are a different color to the bay lengths. As system scaffolds increase the number of distinct lengths available, it's become increasingly difficult to identify items that are of similar size from one another. For example, Here, a 1.27 metre ledger is similar to a 1.04 metre ledger. So if the 1.27 metre ledger is physically painted or marked grey and the 1.04 metre ledger is marked red, and they are sitting in a pallet or a pile on the ground, they can be easily identified in the yard or by the scaffolders on site. Here's a page from the AppPack catalogue, and you can see that the 0.84 metre and the 0.88 metre ledgers have their own distinct colour codes, so they're easily identified from each other when they might otherwise need a measure tape. The iScaf 11 2026 release introduces the option to show distinctly colour-coded length and width ledgers and transoms in both 2D plan layout and in 3D. To demonstrate, we have built a 3D dance floor with colour-coded ledgers and transoms. The distinct colours make it very easy to identify the length of the ledger or transom in question. So for our third demo, we will show the new iStairs command that allows you to answer a few basic prompts about the stair profile, including landing and step depth and height, the number of stairs, and the width of the stair, that will very quickly create a 3D sloping profile or surface that can be joined together in multiples using the union command to create a complex slope. We've done exactly that here for our stair concourse and added a 3D solid building at the back. We've built a complex scaffold against this using the slope that's been defined by the stair parameters. As well as rendering a professional-looking output for your clients, the new iStairs feature can save a lot of time in estimating a complex job like this. Thanks for watching, and remember the scaffolding software team is on hand to assist you in your daily drafting and estimating needs.